Alright, here's the second part of this 5.1 and 5.2 video. Now that we've defined polynomials, let's ask ourselves if these are polynomials or not. Well, is this a sum of monomials? And is this a monomial? And is this a monomial? Well, yeah, this is just a number times two variables. Well, actually times a lot of variables. And a variable times other variables. So, yeah, these are monomials. So here we would say yes. And we would even, if we wanted to classify it, we would say that this is a fifth degree because it has 5 as the highest power. And it's got two terms, so it would be a fifth degree binomial. Over here, well, this is a monomial and this is a monomial, but this is not. So this is not a polynomial. Okay, let's go into the actual math here. Okay, this says to simplify. Now, the main thing I want you to see here is if you got a negative sign outside of a parentheses, all we're doing is adding all these terms together, but the negative sign you need to distribute to every term, so it should look like this. Notice that I distributed the negative to every term. Okay, now let's combine my like terms. 3x squared minus x squared. Let's do this with some color. So these are like terms. These are like terms. And the numbers I didn't underline. So we would get 3x squared minus x squared is 2x squared. And negative 2x and negative 4x is negative 6x. 3 plus 2 is 5. There we go, we've simplified that expression. Alright, what if we're going to multiply? Well, let's take a look. I got 2x times 7x squared. Well, 2 times 7 is 14, and x times x squared is x cubed. But remember, I got to distribute this to all these terms. So, 14x cubed plus negative 6x squared plus 10x. Alright, now some of you guys, when you see this, you go, oh, well, can I pull an x and like a 2 out of every term? Yes, you can. Then that would just get you back where you started. That's called factoring. That's not what we're doing right now. Okay. Why don't you guys do this one on your own? I'll pause or you guys should pause the video because I'll put the answer up in just a second. Okay, so negative 3 times 4 gives you negative 12x cubed. This gives you a positive 6x squared, and this gets you a positive 9x. And there's that answer. Okay, pretty easy, just distributing that number through, multiplying each term by the number on the outside. But what happens if we're going to multiply a polynomials? Like multiplying, like in this situation, a trinomial times a binomial. Well, for this, you need to use the box method, okay? So I'm taking the the trinomial, and I'm putting each term on top, n squared, 6n, negative 2, and then the n in positive 4 on the side. And I'm just going to multiply every term. So n times n squared is n cubed, 6n is 6n squared, and negative 2n. Then you get 4n squared, and you get 24n, and you get negative 8. And if you're not missing any degrees, so notice we have a power of 2, that's a power of 1, technically this is a power of 0, this goes 1, and then 0. So if we're not missing any degrees as we go down, like if this isn't just n squared and then going straight to a number, then we should have this pattern where we get common terms or like terms at an angle like that. So now we're going to add all these terms together, and we get n cubed. 6n squared plus 4n squared is 10n squared. 24n minus 2n is 22n minus 8. And there we go. We've got our solution to what happens when we multiply these two things together. Okay. Now, you've probably heard of FOIL before, and FOIL is fine, but it only works for these types of situations right here where you have a binomial times a binomial. You can't use FOIL here because it doesn't work. It doesn't get you your answer because it'll leave out this term here. So when you do have a binomial times a binomial, you can use FOIL or you can use the box method. You can just have a box that's 2 by 2. Up to you which way you want to use. I really don't care, but go ahead and give it a shot. Try this answer. I'll put the answer up in a second. I'm going to use the box method when I do it. Okay, so I did the 5y plus 4 on top, the 3y plus 2 on the side. You could switch it, it doesn't matter. And I got 15y squared, and because it went 1 degree to 0 degree, 1 degree to 0 degree, I have this little pattern where these guys are my like terms. So I added those together to get 22y, and then I have an 8. And so that should be my answer when I multiply those two things. Okay, last thing I want you guys to try here is this challenge problem. Let me show you how I'd set it up. Because you got 4 terms, 3rd degree, 2nd degree, 1 degree, 0 degree, 2nd degree, 1 degree, 0 degree. So you got 4 terms here. I'm going to put the n squared over here, 6n and minus 2. So you got 3 terms this way. So there's a lot going on here, but as long as you organize it in the box, it gets pretty easy. Try and figure out your answer there. I'll put the answer up in just a second so you can see it. Okay, I'm looking through this and hoping I didn't make any mistakes because there's a lot going on here. But here's what my box looked like when I filled it out. And because everything's in the right order, 3rd degree, 2nd degree, 1st degree, 0, I have like terms at these angles, like so. And so I have n to the 5th plus 2n 4th minus 24n cubed plus 27n squared plus 38n minus 14. That's what I got when I added all my like terms and wrote it out. Should be your answer. And that's it for this video. See you guys in the next one.